All right, good afternoon, everyone. Welcome to today's webinar. My name is Jessica Seward. I'm the Director of Demand Gen here at ThreatConnect. I'm going to just take a minute to go over a couple housekeeping items, and then I will hand it over to today's speaker. So first, I want to let you know that everyone's phone lines are muted to keep background noise to a minimum. So if you do have questions, please ask them by typing them into the chat feature on your webinar console. We'll answer all questions at the end of the webinar. Second, the webinar today is being recorded, so we will send out that recording as soon as we have it available, either probably tomorrow or the next day, for anyone who wants to review it again. So now I think that's it for me. I'm going to turn it over to June.
All right, thank you, Jessica. Hello again, my name is June. I'm one of the security engineers at ThreatConnect. So we are going to talk about, as you are, and by the way, thanks for joining today's webinar. So I wanted to talk about the recent the emergency directive that was published by DHS, and how we can effectively manage the ongoing risk as a using a solution that we offer. So a few, here's some list of agendas that we like to share. So like I said, I'm going to quickly go over the what exactly was discussed in the emergency directive, as well as how we can continuously mitigate any potential threats in your DNS infrastructure. All right, so here's my quick intro. So I don't know, I hope you guys would have heard of ThreatConnect, our company. We are one of the pioneers in threat intelligence platform, as well as a SOAR engine that comes as part of that package. So, our platform was designed by security analysts. That's been built for the team, and we have currently about 20 or so agencies as federal government agencies as a customer to date. I actually work with a team of specialists in the federal sector to help them answer any difficult technical questions. So, this is one of my opportunities to kind of give you guys an overview on what's currently going on and what we can do to help you. All right, so I'm gonna move on quickly to discuss the. Oops, here we go. All right, so what was that about, right? DHS Emergency Directive 1901. So DHS has time to time publish different levels of directives to a civilian as well as military agencies that's under their purview, usually towards civilian agencies. So department, for example, Department of Energies or Department of Interior and etc. But until earlier this year, there have never published a emergency level directive in the past. So there are a number of different levels of directives that DHS publishes and requires certain actions to be taken by these federal agencies. Now, emergency directive is the highest level of directive that requires an immediate attention by all these civilian agencies, in this case, in 1901 in particular. So we can, by just the fact that it was their first time in history publishing an emergency level directory, we can tell this was a serious issue that we were dealing with. So what exactly happened and what are the series of events that took place that transpired to DHS issuing a emergency directive? So what happened was DHS and its organizations that it has, they have a team of cybersecurity professionals whose main goal is to protect the American and their federal government systems and their networks and their assets, basically. And as part of their investigation, they've discovered a serious and ongoing campaign that actually managed to hack into several civilian agency infrastructure. And that's pretty much the extent of disclosure that they included in as part of the directive. So we don't know what's the true extent of the damage and the scope of that campaign that we have observed. But basically, there was a tampering attempt, an actual successful tampering campaign that into a DNS infrastructure into some of the civilian agencies' computers, DNS servers. So as you all know, a DNS is basically a system, and usually a server or two that usually sits internally within their network infrastructure that translates a host name, for example, google.com, into an actual IP address. So when you send an email, this is critical piece of infrastructure, because when you send an email, usually you don't send it to an IP address. You usually have someone's ID with a @ and then followed by some host name. So those host names get translated by usually for a larger organizations by their internal DNS into an IP address. Then their destination is then set before it's actually sent out by the email server. So you can kind of tell, you can see that if you have a control over the DNS server, you can tamper with the hostname resolution, where basically you can alter, in other words, you can alter the destination for where that particular information packet or the email or whatever browser activities that is going to end up in. So this was a serious, very serious and potentially likely a widespread issue. So that's why the emergency directive was issued. So here's a quick, so it's sort of like a man-in-the-middle type of attack, right? So instead of having the intended packet to be routed to an intended destination, these bad actors can come in, hijack that traffic, I guess, either first to their location and then have it forwarded to the actual intended destination, so they can also stay hidden without making. So basically what they can do is they can receive, open the packet, inspect the payload, and then package that back up and send it to its intended destination, so that they can sort of remain hidden, but still allows them to maintain a tap into your information stream, right? So as part of the DHS Emergency Directive 1901, what they required the civilian agencies to complete were these 4 list of actions that needed to be completed within fairly short amount of time. So that was back in January. All of these should have been completed by now. They are, obviously you must audit your DNS records, meaning that if you have any manual override in your DNS server entries and your resolutions, you have to make sure that they are correct. And also change the DNS server administrator's account password, as well as adding a 2-factor, or sometimes called multi-factor authentication, to further safeguard the DNS server admin account if it's not already in place. Now, lastly, you have to monitor your certificate transparency log, mainly because if a bad actor has a control over your DNS records, and they can change the DNS resolution to whatever IP address that they own, then they can also circumvent any certificates. They can go ahead and create their own certificate, so that these traffics are basically going to a known address, an address that's known to DNS to be correct, although they are owned by somebody else than your originally intended recipient. So there's no way to really confirm whether this certificate is valid or not unless you look at them manually and confirm that the destination IP address is correct. So there are a number of different issues that this can potentially cause. But as you can see, if something like this happens, and it can pretty much go undetected for a while, meaning that an adversary has basically a wide like a tap into your information stream that's wide open that can go undetected for a long period of time, right? So now what? So these 4 actions that you take, they're great. So it allows you to at least audit your record for that at that time frame at least once. And I'm hoping that all of your agencies have completed all these actions. But it doesn't necessarily require you to continuously monitor your DNS resolutions, meaning that, so your DNS records and your DNS cache in your DNS server were validated, audited, and either you found some issues which have been corrected at the time, or you found no issues, so that's fine. You satisfied the requirements that's laid out by this emergency directive. You're honky-dory, but not so much, because even if you beefed up your security, there could be a different another 0-day attack that can still give these adversaries an access into your DNS infrastructure, thereby changing your again tampering with your DNS records. So really there's no safe there's no panacea to safeguard your DNS server from being hacked, just like any other infrastructures that's out there. So the key is to continuously monitor your DNS records for any unauthorized alterations, right? So that means you have to hopefully maybe at least once a day, or maybe a couple times throughout the day, you would have to make sure basically you perform a continuous audit in your DNS records resolutions. So that's really is the only way to prevent, or not necessarily prevent, but at least detect at the earliest hour if anything happens to your DNS records. Now, it's fairly simple task, really. At a high level, what you need to do is basically maybe take, for example, you have ThreatConnect.com, right? So you can check against your DNS, internal DNS server, to see to which IP address it resolves to. Now, and take the same host name and run another DNS resolution against a well-known public DNS, for example, Google's public DNS IP address 8.8.8.8 that a lot of folks use. You can also run the same DNS hostname resolution against Google's public DNS, and to see if the Google's DNS returns the same IP address as as your own internal IP address, right? So hopefully, and then for the most part, they should match. But if there's a mismatch, that means, and potentially you would also run this against the second set of the public DNS servers just to make sure you have another data point. But all 3 must match. If your DNS server returns a different IP address as for the host resolution, that means there's more than likely it's more than likely that that particular host name resolution has been tampered with. So somebody has gained access into your system, into your DNS server, manually overrode the ThreatConnect.com resolution to say, IP address 1234 instead of IP address 1234. Now it's pointing to IP address 5678, for example, right? So the only way, and this is really the only surefire way to detect how, detect any tampering activities that can potentially be occurring within your DNS, right? So here's another quick example. So, kind of visualizing that what I've just mentioned. So my Google public DNS is these are actual examples, by the way. So one of the Social Security admins mail server is, it's according to their MX records, it's mailin1.ssa.gov. And when you do try to resolve this to a IP address, it returns 137.244 and 7. So your own DNS server should, hopefully return the same IP address, in this case, it's good. So we have a match. We don't have to worry about this particular record. So we can move on. Now, here's another example. This is another example of a mail server, in this case belonging to Navy. Mail server, I guess 13 among many. Google says it resolves to 205.85.33.247, but your internal DNS says, oh no, we are resolving it to 108.288.159. In which case, oh, wait a second, this is going to somewhere else, some other IP address. So this kind of should trigger a chain of events that starts hopefully in some investigation and trying to find out what's going on, right? Now, the problem with that is how you can't technically, I mean, yeah, you can do this manually. Say, Google DNS has at their public website. You can copy and paste, Control C, Control V, every single, cached DNS records into your web browser and check one by one to see if it works. And that should give you some idea. Or maybe you even have like 100 or so list of important host names. For example, your other federal agencies or other contractors and etc. But you have to do this every day. So it's a typical boring problem that a lot of us find ourselves wasting our time. The key is to automate this as much as you can, right? So for example, maybe you can take a Python script to do this. Maybe there are some other commercial solutions out there that can do this for you, although I'm not aware of any specific product that does only this, or maybe a part of their package. But the key is you don't want to be doing this every day, or you don't even want to give this to your interns to run this manually every day. It's such a waste of time and energy and resource for just a simple task that can be easily automated. So the key, and that goes along with a lot of your day-to-day tasks. And I find this in a lot of federal agencies. So for example, you probably have an email address that belongs to your cybersecurity team, where you are asking your employees to forward any suspected phishing emails so that they can start or launch an investigation for those emails. Now, for a larger organizations where they have tens and thousands to tens of thousands employees under their care, you could be receiving hundreds of these emails a day. And the fact of the matter is, a lot of these large organizations have multiple full-time employees whose job is whose only job is basically to triage these suspected spam emails. So you can see how it can quickly become a scaling problem, and as well as humans doing these works over and over, they are bound to create errors, although it's not 100% their fault. But humans, we are not always accurate. These tasks like these are better left to computers. That's why we want to automate these tasks as much as we can, right? So and that's part of the problem. That's one of the major problem that ThreatConnect platform wants to solve, and that's what one of the main reasons why we exist is to help cybersecurity professionals and these cybersecurity organizations to do their job more efficiently, and have these boring tasks delegated to a automated system. And we give you the tools and the help that to make that happen along the way. Meaning that we are a platform built specifically for ThreatConnect, these cybersecurity analysts and IT professionals, and we can help you not only gather intelligence, enrich those intelligence, but also automate and orchestrate different actions. So what I have prepared is what I would like to demo to you is an actual playbook that I've created in the last few days, over the course of last couple of days, that will actually perform the automated DNS monitoring actions. So and I'm going to show you the actual live demo in a bit. But what the playbook is basically, think of it as a Microsoft Visio in a way, because it looks almost similar, quite similar. Let me give you a quick screenshot of that. So it looks almost like a Microsoft Visio, right? But whereas Microsoft Visio would only, allow you to create a pretty picture of your work process and your workflow, and it doesn't go any beyond that. It's just there for documentation purposes. Whereas a playbook feature that's included in ThreatConnect platform, each one of these boxes that you see, they actually perform specific actions based on how you want it to. So based on your definition, your design. So I designed this, maybe the overall total time I spend this is definitely less than a day, maybe a half a day at max for this test case. But each one of these we call an app. So these playbook apps are pre-built into the platform. So they, we have hundreds of these apps that comes with the package out of box that will help you to integrate your system with different parts of your IT infrastructure. So a good example will be in the case of email triage, you can automate the parsing out of different parts of the message, detonating any potential malwares that's attached to an email, and maybe even creating a ticket, or even using your Cisco Firewall's API to automatically add certain IP addresses to a block list if it meets a certain threshold that you designed. So it's almost like a programming platform, but instead of you having to become a programmer yourself, it allows you to automate and orchestrate or create these designs and actually run these automation and orchestration straight from the platform using a nice, easy to understand GUI. So let's do a quick demo. So let me switch over to a different screen. Bear with me for a second. Yep. So here is the same playbook, and this is an actual live version that I can work with. So let me zoom in a little bit. So we have a trigger. We have a number of different types of triggers, but basically it's a trigger nonetheless to start this whole process. So in our case of continuous DNS monitoring, DNS record monitoring and auditing, maybe you can have it trigger on timer at 6 a.m. every morning. So by the time your analysts arrive into office, the scan would have been completed and any anomalies would have been escalated by the system. So I'm not gonna go in detail in every single one of these boxes. Just want to show you a high level and maybe a couple of detailed examples. But the workflow, the flow basically goes like this. So at the beginning of the playbook process, it will go ahead and reach out to your DNS server and grab any DNS data sets that you want to run audits upon. It could be any predetermined set of important list of host names, or it can be just some cached DNS records that your server has. So it could be, as little as a couple dozens or maybe thousands and tens of thousands. Doesn't matter. We can still automate it, right? So once that's completed, we're gonna parse out the host name based on, because I'm sure the data format could be something, it could be either JSON or maybe some plain text file. So we have to parse out the host name part so we can use it to perform DNS resolution. So, and for now, once that's done, for each host name, we're gonna run external DNS query using Google DNS. Let me show you an example here. For this particular action, what I have prepared is this app is called HTTP client. So it's a client basically that allows you to create API calls, HTTP post gets and puts and whatever. And here's an actual URL that you use to grab the results from DNS, Google's public DNS. I'm using a get method. The payload of that call is dynamically assigned, based on the host name that was parsed out in a previous step. So you don't have to hard code anything, and it can accommodate any different set of host names. Now, once that's done, it will this guy will pass on the results that was returned from DNS, Google DNS, and I'm going to parse that result out to see to get the IP address that was resolved based on the host name that I just provided in that call. Now, I'm going to compare that against my internal resolution, meaning what my DNS server thinks where that resolves. And then I'm going to ask a question. Does the internal resolution versus Google's resolution match? Is that an equal? So if it's an equal, that's fine. You can ignore that and grab another host name and do the same and over. So you can see this loop could potentially running hundreds and tens of thousands times a day, which is no problem for a machine, but a huge problem for humans to complete. Now, the fun begins when there is no match, right? So the Google's DNS resolution is versus to my internal DNS resolution do not match. So what do we need to do? Well, it's really whatever you want it to do. In this case, what I'm doing is I am going to reach out to ThreatConnect. So remember, ThreatConnect platform is a threat intelligence platform. So it already has tons and tons of different intels in any specific data, like it could be IP address, host names, and whatnot. That's fed into your instance of ThreatConnect from different sources that you are subscribing to. So in my demo system, I have probably tens of millions of different data points. So it's resolving to some random IP address. So I'm gonna first find out if my ThreatConnect knows anything about it. So I'm gonna send the internal resolution, which is going to be an IP address, find out if I know anything about it, meaning does that object exist in my database? If it does not, meaning it's a relatively new threat, my ThreatConnect doesn't know about it, so I'm gonna go ahead and if it doesn't exist, that's fine. I'll go ahead and create one so I can start keeping track of this guy, IP address 1234, for example. Now, if it exists, that's fine, even better, so I'm gonna move on. Now, what I can also do is we have an app for VirusTotal enrichment. So I'm sure a lot of you guys would know what the VirusTotal is and what it does. So we have a pre-made app for this. So it will go ahead and reach out to VirusTotal using the API token that I provide, as you can see. And I'm gonna pass, that suspicious IP address and try to grab any information that VirusTotal knows about. And I'm gonna go ahead and save that result so I can have some record of what's going on into that object. Now, lastly, I'm gonna go ahead and create a task, meaning I'm gonna assign this to one of my analysts so they can, first thing in the morning they will see when they come into the office is a task waiting for them, asking them to investigate this potential this IP address resolution mismatch a potential, tampering campaign that's occurring in my system, right? So pretty simple, nothing really exquisite about this, but the key is, that you can automate this. And not only that, of course I designed it this way, but you can design it however you want. You can actually have it, instead of creating a task, you can go ahead and have it send an email to the team. So we have a email client, as you can see. I click on that. Here you go. And it will go ahead and send an email for me, as long as I give it, the email address and then, and these required parameters, right? So I'm gonna have it send me an email. Let me give you a better view. There you go. And so when I open this up, it's pretty simple. Who's the recipient? So I'm just gonna put my email address, not Gmail, ThreatConnect. And then, subject here, potential, actually, yeah, DNS resolution mismatch, for example, right? Check, please investigate this IP address. And what's the IP address? It's parameterized, so I can just grab that IP address that was resolved and being passed into this box as a parameter, as you can see, so they will know what to do. So hit save. Now, in addition to creating a task, it's going to also send an email out to, well, me in this case, but of course you can do whatever you want. Slack, we also have a Slack client and etc. And hundreds of different client apps you can play with. And if the integration that you want to work with doesn't already exist, you can just use the generic HTTP client I used earlier to query the Google public DNS record. That's basically what I did, because we don't have an app for that. I just used the HTTP client app. Or better yet, you can go ahead and create your own app. We have an app builder, which is basically a Python IDE that's built directly into ThreatConnect. So here you can create your own Python apps and have it debug, function available. Looks like this one is not pulling up, but basically you can import your own custom Python package, etc. So you can be pretty creative if that's what you want to do. And once that's ready, you just import that new app you just created into the Playbook and make it run. So what will this? So that's pretty much the gist of what's going on. And let me show you how this actually runs. So I made sure this runs last night, so it should run. So what I'm gonna do is I'm gonna go ahead and activate this guy. And on a separate window I have, and you can see past executions that has run before. A couple of failures as I was just doing some debug and playing with different options, but what I'm going to do is I'm going to go ahead and kick this off in a different window. Again, it can be kicked off in a number of different ways. I'm just doing it manually, so I can kick it off on command. And right off the bat, there's a new execution, a new session that's running right now. And you can actually follow it step by step live as each step is being executed. So my trigger was executed. My internal DNS data was retrieved, and host name has been parsed. And for each step, you can actually debug it. Based on your log level, you can check what was the input data that was passed into this particular step and what was the output data, right? So think of each of these apps or steps as sort of a function, but you get the idea, right? And comparing resolutions, it was an iterator. So if I click into it, I actually have the number of total iteration that took place. And once it's complete, it will tell me whether it succeeded or not. It's basically at each step level, at the level of each step, as well as the entire playbook. So in this case, it succeeded, and it will show me, at which step, which path, graphical path it took. So it's pretty cool stuff. you can actually follow one by one, and even the past executions you can follow one by one. So you just scroll up and down. I can see the one from last night that I was playing with. You can kind of follow them along one by one and look at the data that came in and out of those individual steps and etc. So pretty powerful stuff to, so it allows you to debug different functions and your steps. So what you can do is basically, my trigger is manual trigger right now, but what I'm going to do is I'm going to put it on a timer trigger, remove that, put this on timer that says run daily at 6 p.m. It's going to be just the name that will show up on here on screen. Let's do 0600. So they will just repeat, faithfully once a day. It's at 6 a.m. Your local server time, and happily run through all the data it's given, and do what you want it to do, right? So that's basically what a playbook is, right? It's pretty cool, pretty powerful. There isn't really much it can't do. I mean, matter of fact, as an end of this step, you can even have another HTTP client that will reach out to your Starbucks API and order you a cup of coffee and get that order data over to Uber Eats API, send that over to Uber Eats API, and have the driver pick it up and deliver it to your office. You can do that too if that's what you fancy. But I just wanted to kind of show you, give you the example how expandable this platform is, and how extendable the platform is. So, but of course, we already have a more serious professional type of integration that's already built in. So you can make binary malware binaries with Cisco Threat Grid and etc. These actions are already built in. So the only thing you need to do is just plug your parameters, your API tokens, and that's about it. So let's let me take you back to my excuse me, the slides real quick. I think this is it. Yep, there you go. All right, one thing I wanted to point out, since I work with the federal team, is that ThreatConnect platform as a software has recently been approved by DHS to be put on a CDN list. So if that's what you require, if that's something that you need to go through for, to make your, acquisition easier, we have that prepared. That's already been completed. So that's one really a huge effort on our part that we were working on over the last few months, and it's finally completed. So I'm glad it was completed before today's seminar, so I can tell you this good news. So that's just wanted to give you a quick tip on that. So that concludes my technical part of this seminar. I didn't want to have to make you sit through the entire hour, so I wanted to make sure I give you some time back for the before the hour. So, but if you have any questions or comments, I'll be more than happy to answer any of those. I think Jessica has been collecting some of those questions along the way.
Yep.
Do you have any? Yep.
Jessica. Hey June, yes, we've had a couple questions come in. We had a couple people ask about the recording, and we will be sending that out probably tomorrow or the next day. As soon as we have the recording ready, we'll send that out to everyone. And then let's see, we have another question here from James. It says, is there a limit to the number of host names you can scan?
Yep, so thanks for the question, James. The answer is no. So basically, there are no hard limits as to what you can do in playbooks. So the playbooks are, they basically run on platform on command or on schedule, obviously. And so you can just send it, as many as little as 1 host names or as many as 1 million host names. Of course, it can be a little bit taxing depending on your hardware specs, but no, the answer is no, there are no issues. The There are no hard limits as well on the number of playbooks that you can have or you can run at a time, or the number of executions that you can run per playbook. So it all depends on, what kind of hardware you're trying to run this on, and how resource intensive those particular playbook actions are.
Okay, thanks, June.
Sure.
Next question coming to us from Megan. Is it possible to automatically create a ServiceNow ticket when DNS resolution issue is detected?
Yes. Yeah, thanks for the question, Megan. So basically I showed you earlier as part of my live demo how you can add an extra step of sending an email at the end of the process. You can pretty much do the same. Matter of fact, we do have a Create ServiceNow Ticket app already built into the platform as part of the Playbook feature. So you can just add that one box in there, enter your URL or your basically tell the app where to find the ServiceNow, host names, port numbers if that's applicable, your ID and password or API keys that you want. You need to access and create some records in there, and the relevant information you want to create the tickets with, and that's it. And it will magically create a new ticket for you at the end of the step whenever there's an issue in your, basically on the second stream that you have. In the case of no match, then it will just have that additional step to perform.
Okay, cool. We have, let's see, one more question here. This one comes from Chris. Are playbooks scalable? Can you have multiple playbook servers to distribute?
Yes, I'm glad you asked. So the playbooks are scalable in a sense that you can have multiple playbooks, but at the same time, your playbook execution can be scalable too. So meaning that, say, you start with a single playbook server, it could be just the same running on the same hardware as your main app server, but say you have quite a few playbooks, or maybe a couple of playbooks that runs constantly, so you need more hardware, RAM, memory, CPU, or whatever physical resources. Then you can just go ahead and add another playbook server that will handle the extra load. So think of it as sort of an distributed processing units. So the ThreatConnect platform and its playbook features come with these resource management built in. So you can horizontally scale out the, I think vertically, horizontally, yeah. But either way, you can scale. So you can basically add any additional number of playbooks servers. So even if your load increase, you can accommodate those increased load by adding additional hardware to share the load. And also another feature is that playbook is, if you have maybe one or two important and mission critical playbooks that needs to run on time, or it must run as soon as it's triggered, and you cannot have it be queued up because your playbook servers are all busy running other playbooks, what you can do is you can spin up another playbook server and dedicate that playbook server to only run those two mission critical playbooks. So those two playbooks would always have hardware resource to reserved for them to run whenever they need to run. So you can do that. You have that option as well. So again, this is the ThreatConnect is a enterprise grade software. So that will be used by mission critical cybersecurity teams for mission critical tasks. So we designed it this way, so they are given these options as needed. Any other questions?
Looks
Jessica?
like that's, right. Yeah, I'm here. Can you hear me?
Yep.
It looks like that's it.
Okay.
So if anyone does have any more, you see June's email here, you can feel free to reach out. I think that's it from us. Thank you so much, June.
All right, you're welcome. I'm glad I was able to discuss this topic today, and I had a lot of fun preparing for this, especially building the playbook. So if you have any questions or want to geek out basically with me about this topic, please feel free to reach out to me. I'll be more than happy to talk about it.
Great, thanks, June. Thanks for
All right,
joining, everyone.
sure. Thank you.